Welcome back. This is Nick Agram. I will be discussing inverse functions. I'm going to give an example before we can generalize it, okay? Let's see. If I have here now f of x is equal to 3x minus 2, and the notation for function is f of x, and for inverse function we have f raised to negative 1 of x. That's the notation. Okay, so if we're going to find the inverse, finding the inverse, is that we have if we're going to transform this y is equal to 3x minus 2, then just interchange the x and y. So my y will become x is equal to my x become y, 3y minus 2. Okay, and then I'm going to solve for y, or I'm going to isolate y. So if I'm going to add both sides of the equation by 2, then I have x plus 2 is equal to 3y. This is now 0. If I divide both sides of the equation by 3, then I have x divided by 3 plus 2/3 is equal to y. This is now my inverse function. If I'm going to write that in inverse function notation, then f raised to negative 1, the inverse of x is equal to x divided by 3 plus 2/3. As you can see here, in arithmetic, you know that if I have 2, the inverse of that is 1/2. So if I have 3, the inverse of that is, of course, 1/3. As you can see here, I have 3 times x there. That means my inverse will become 1/3. Okay? And one that you can control if you have a graphing calculator is that if you're going to put that now, 3x minus 2 and then x plus 2, actually you can group them together divided by 3. If you're going to draw that, or these functions, then you can see that they reflect the reflection of each other. That's one control if you have done a good job finding your inverse. Another is that if I'm going to find the composite function of f raised and f of the inverse of x, this should be equal to x. We're going to prove that this one is also equal to x. So if I have f of inverse of x, we have x divided by 3 plus 2/3. And then we have now 3 multiplied by our x now is x plus x divided by 3 plus 2/3 minus 2. And then if we have 3x divided by 3 plus 3 times 2 divided by 3 minus 2. And this is now x, and this is now 6 divided by 3 is 2 minus 2 is 0. Then we prove that the composite function of f and its inverse is always equal to x. To summarize, if we have y is equal to the function of x as an inverse function, this new function should be denoted by this. Must indeed be a function, and so must satisfy the vertical line test. Okay, and the one I showed you, it satisfy this line satisfies the vertical line test. Okay, is the reflection of y is equal to f of x in the line y is equal to x. Satisfies also this one, the composite function of inverses, function and the inverse, it should be equal to x. And we did that. Okay, let's try some more example. Here's another example. We have 2x plus 3 divided by 5, the function of x. Sorry for not mentioning that. So we have y is equal to 2x plus 3 divided by 5. And then to find the inverse, we need to interchange. We have x is equal to 2y plus 3 divided by 5. If we multiply both sides of the equation by 5, then we have 5x is equal to 2y plus 3. And then we subtract both sides of the equation by 3. Then we have 5x minus 3 is equal to 2y. Then we have divide it by 2. Then we have 5x minus 3 divided by 2. That is our function, inverse function. 5x minus 3 divided by 2. To check if you did right, then you have 5f, the composite function of its inverse. It should be equal to x. So you have f, the function of 5x minus 3 divided by 2 is equal to 2 times 5x minus 3 divided by 2 plus 3 divided by 5. Then we have if we divide now, we have 5x minus 3 plus 3 divided by 5. This is 0. Then we have 5x divided by 5 is x. Now we are quite sure that our function, we find the right inverse function of this function. Okay, I hope you learned something anyway. Inverse function can be difficult if you don't understand, sorry, but keep on practicing, then it might go well for you. Of course, we can complicate this. We can look for the sign diagrams, the domain and range, and everything, the graph. And in my next video, I will be discussing functions again, but it will be concentrating on transforming functions. So please watch again if you like what I am doing, and if you really like it, please like it, push the button like, or subscribe to my channel. Have a nice day. Thank you for watching. See you soon.